In this video, we will solve the initial value problem of this differential equation, and it is called the initial value problem, or the IVP, because the initial condition of the differential equation is given. So the first thing we should notice is that this differential equation, it's not separable, because, so recall, so in a separable differential equation, I'm just gonna denote it as DE. The differential equation follows some form of such. So if we're dealing with the variable y and x, so dy over dx, then it is equal to a function in terms of x and another function in terms of y, where they're like multiplied together. But in this problem, we see that we have a term that is added. So we know for sure that it is not separable. So say that this is not separable. Okay, so we can also rewrite this given differential equation. So 2y prime, so y prime is dy over the other variable that we're dealing with in this case is dx, so it's going to be over dx plus 4xy equal to 2x cubed. So if we're like not sure if this is separable, we can prove again by solving for dy over dx and see if we get to this form. So if we solve for dy over dx, we will let's say the first step is to bring the 4xy to the other side, so 2x cubed minus 4xy, and then we can divide the 2 on both sides to get dy over dx equal to x cubed minus 2xy. So in this case, all the terms, either in terms of x or y, they're multiplied to one another. But in this case, it's subtracted to one another. So that's an indication of, another indication of saying that it is not separable. But we can solve this differential equation by using integrating factors. So with integrating factor, we're trying to get the differential equation into this form of y prime, any term with the y in it, and then any term with x, the variable x in it. So the c in this case could represent two different constants. And just a side note, the y prime, it's the same thing as dy over dx. The key thing about this form is that the y prime, or like the dy over dx, should have a constant of just 1. So going back to our differential equation, we have a 2, constant of 2 in front of the dy over dx. So we get rid of it by dividing 2 on both sides. So it becomes dy over dx plus 2xy equal to x cubed. The next step is to take the term with y, and then we just take the whatever it is in front of the y. So in this case, it's 2x. So 2x would be equal to, let's say, our function of ax. What we should do is we should integrate this function a of x in terms of x. So that's the same thing as integrating 2x dx, and we get x squared. So x squared, with that we simply put an exponent on it, so it will become e to the x squared, and that here, e to the power of x squared, is our integrating factor. So that's why this method is called the integrating factor. So now that we have this, let me just move this up some. Okay, so now that we identified our integrating factor, we just multiply this integrating factor to both sides of the equation, So it becomes e to the x squared times dy dx plus 2xy times e to the x squared, which is equal to x cubed times e to the x squared. In this equation, this holding here is basically equal to the derivative of this function, e to the x squared times y equal to x squared, e to the x squared x cubed. And this holding here, it's equivalent to the derivative of the integrating factor, so e to the x squared times the variable y, and equal to the right hand side, so x cubed is equal to x squared. So let me just write it down here, maybe it will be easier. So from the right side, you could simply see I simply brought like the right side down, and on the left side you can see that if we take the derivative of this, we can simply get to this thing by using the product rule. So I can do the variation on the side really quick. So let's say we have this thing here. I'm just gonna rewrite it over here. So the derivative of this x, e to the x squared y, and then let's do the product rule. So it will be the derivative of this first, so e to the x squared becomes 2x e to the x squared, and simply y, and then if we take the derivative of y, it becomes 1, so it becomes e to the x squared y prime, or in other words dy dx. So you can see that this term here is the same thing as this term here, and then this term here is the same thing as this term here. So that's why this term is equivalent to this. It's by product rule, and then the right side, just simply copy it down. Okay, so now we just simply integrate both sides. So if we integrate the left hand side, this symbol, which is taking the derivative and then taking the integral, will simply cancel them they will simply cancel each other out, because taking the derivative and then taking the integral. So the left hand side will simply become e to the x squared y times y, and then the right hand side will be the integral of x cubed times e to the x squared dx. So now that we have this equation here, we will simply integrate the right side and then solve for y. So let me just copy this integral to here, so I have more space to work with. So simply copy this equation here. Okay, and then we will integrate the right side. So so this, with this integral, let's see, we will perform u sub. So u, in this case, I will pick x squared. So du would be 2x dx. And then if we divide 2 on both sides, we get that. Okay, so if this might be a little tricky, but so if we separate let's say x squared times x, so we see that's x cubed, and then e to the x squared dx. So we can see that x squared from here is equal to u, so we simply substitute integral of u, then there's the variable x, then e to the u dx, and then we see that once we divide by 2, the 2 cancels out here, so x dx is equal to du over 2. So here x dx, so that's equal to 1/2 du. So u times e to the u, then 1/2 du. Oops, du. So that simply we can rewrite this integral, so it becomes let's bring it out, 1/2 the integral of u to the u times e to the u power du. Next, we will solve this integral by using the integrating by parts. So let's say our w is equal to the variable u. So our integrating by parts, I'm thinking of separating these two functions. So one of them, w is equal to u. So dw, once we differentiate u, it will be 1. And then our dv will be equal to e to the u power. So once we integrate dv to get v, we get e to the u power. Okay, so this thing becomes I'm gonna use brackets so we don't have to worry about the distributing the 1/2 as of now. So by integrating by parts, we get u times e to the u power minus the integral of e to the u power du, and then we can integrate this, so we get integrate this part, so we get u times e to the u power minus e to the u, and then because we're dealing with the indefinite integral, we have the plus c constant. So we can distribute the 1/2 into the brackets, so we get 1/2 u times e to the u power minus 1/2 e to the u plus c. And then from the very beginning of our integral, we get that u is equal to x squared, so let's substitute that in. So 1/2 times times x squared, e to the x squared minus 1/2 e to the x squared plus c. So that's our right hand side, and our left hand side, let's bring this down. So we get that it's e to the x squared times y. Solving for y, we get y is equal to 1/2 x squared minus 1/2 plus c over e to the x squared. So this is our general solution. but we are not done yet because this is our general solution, but we are giving the initial condition for this problem, so we are able to solve for this variable c. So now using the information of this general solution and our initial condition, we can solve for the variable c. So I just rewrote the general solution down here and also rewrote the initial condition. So in this problem, we see that x is equal to 0, y is equal to 4. So let's substitute that in. So y is equal to 4 and x is equal to 0. C e to the 0 power. Okay, so now we see that c is the only unknown variable, so we can solve for this. So this becomes 0 minus 1/2, and then e to the 0th power would be just 1, so it will be c over 1, which is c, that is equal to 4. So solving for c, we get that c is equal to 9/2. Now we simply substitute c in, so y is equal to 1/2 x squared minus 1/2 plus c, which is going to be 9/2 over e to the x squared. And this is our answer for the initial value problem.